Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, with one of many videos available to you 24 hours a day, 7 days a week. In the part that we see on the screen, we'll illustrate the use of SolidCAM 2.5D milling to machine the part as shown. The machining is performed on a 3-axis CNC machine in one setup. Now, the following SolidCAM operations are created to perform the machining. First, we start with the upper face machining, face mill, as shown over here. In this operation, we use a 40 millimeter face mill, as shown. The geometry itself is the boundary of the entire part, which is chosen in our geometry window. If we go into edit, you can see the actual boundary that was created by using a box around the model. In our levels, you'll see we'll be working from a 0.5 millimeter above the part itself, which is the stock material above the part. And in our technology, we'll be using hatch to clean the face, going back and forth since the tool itself is smaller than the actual width of the part. Also in our technology, if we go into hatch, we'll be finishing the corners as we go from one slice to the next using a fillet. Taking a quick look at the simulation, if we take a look at the tool path itself, you'll see the tool goes down, across, and as it gets to the edges, it works around in a fillet until it finishes the entire face. In our next operation, we'll be doing the external contour machining around the outside of the part. If we go into the operation itself, you can see the geometry is the actual boundary around the outside of the part as shown over here. The tool in this case will be a 16 millimeter end mill. And if we go into our technology, you'll see that we'll be going down every 5 millimeters for a total of 3 step downs on the part, leaving 0.3 millimeters offset for the finish. When we finish the down step, we'll also be doing a finish cut to finish off the 0.3 millimeters that was left of excess material on the part itself. Taking a look at the simulation, you can see the tool will go down around the part 3 steps and then do a finish cut at the very end to finish off the outside contour. Now we'll look at the island and pocket machining done on this part itself. The islands in this particular case, the first case is talking about this floor over here, this being an island inside that area over here. We're using a pocket operation for that, as well as this floor over here being open on all sides, and these 2 nubs acting as an island. The third operation is just a regular pocket operation over here, cleaning out this entire pocket. If we just take a look at our first operation of the pocket, being this area over here, you can see that the geometry, looking from the top view, is the outside border as shown over here. These areas marked in black represent the open edges, and the island itself being this area around over here, chain number 2. The tool in this particular case will be a 16 millimeter end mill, and in our technology, we'll be using the contour option with the open pocket option of use profile strategy. Taking a look at the operation itself, you can see that the tool goes down on the part using a profile strategy to clean off those areas over there. Complete pocket using a profile strategy, leaving the area of the island. The same thing is done in our next operation, cleaning off this area over here, again using the profile strategy. In the next operation, we have our regular pocket operation, where the geometry is just a regular closed pocket. In this particular case, we'll be using a 10 millimeter end mill, and in our technology, note there's no open pocket option because no open pocket exists. using a regular contour operation on this part. Taking a look at the simulation, you'll see that everything is milled out inside that pocket. And you can also see that the penetration into the part itself was using a helical ramping in order to penetrate into the part. In our next two operations, we'd like to use the rounded corners for cleaning out the rest machining on these corners over here. In the first operation, we'll be using a 3mm end mill to clean out the corners. The geometry is the exact same as the pocket that was used inside before. And since if we go into our technology area, we're using the option of rest, it'll only work in the areas where the previous tool, the larger tool of 10mm, was not able to finish. The same thing is with the next operation in these corners here as well. Taking a look at the simulation itself, you can see that the corners are being cleaned out as shown over here, as well as the outside corners being cleaned out as shown over here. In our next operation, I'd like to actually clear off the chamfers that we need to do on these edges over there. So for that, we have our regular profile operation as shown over here. If I were to open it up, you can see our geometries, those four edges as chosen over there. The tool in this particular case will be a chamfer drill of 8mm with a 90-degree angle. If I were to go into my levels, we'll be going down 1mm, and we have our chamfer option chosen, having 2mm of the chamfer drill being used in order to create that chamfer. Taking a look at the simulation, and I'll use Solid Verify to show the simulation on the part, you can see the tool going down, creating a chamfer on every one of those edges, exactly the way it was programmed to do. In our next operation, I'll be working on this slot over here using the TSlot operation. If I were to open up the TSlot operation, you can see the geometry chosen inside the slot itself. The tool that I will be using will be a 36mm TSlot tool, and we have our upper level, the top of that slot over there, and the TSlot depth is up until this floor. And in the technology, you can see we'll be doing a finish cut on the ceiling, wall, and floor. Taking a quick look at the simulation using Solid Verify, you can see the tool goes down across the part, milling out the entire slot. Now, in the rest of the operations, we'll be drilling out all of the holes that we have in our part. The bigger ones, the smaller ones as well. We have these operations over here using a spot drill to drill out a spot for each one of those holes according to the particular diameter that we have of each one of those sets. Then we have a separate operation with separate tools for the diameter for each and every one of those holes as shown in these operations over here. Running a quick simulation on the entire part using Solid Verify, you can see our first operation does the face mill on top. Then we have our profile operation, our pocket with the island, our pocket with the smaller islands, our next pocket over here, finishing up the corners in the pocket as well as the profile, putting the chamfers on top of these edges over here, the T-slot, the spot drills in every single one of the areas, then finishing off the rest of the part with all the proper drills needed to finish off the part. For more videos on SolidCAM Professor, Please go to our website, www.solidcam.com, and look for the tab called SolidCAM Professor. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.